In this lesson, you will learn to use laws of exponents to multiply a polynomial by a monomial. Now, as we begin, there are 3 laws that we are going to discuss in this lesson, followed by 9 different examples to explain the different laws. So as we begin, I'm going to show you the first law in action, and then we're going to generalize to give you the law itself. So here we see 5 squared times 5 to the 4th power. So our objective is to simplify. Well, remember, 5 squared means we have 5 multiplied by itself 2 times. So what that would be a 5 times 5. We have 2 5s multiplied together. So we see that right here. We have 2 5s multiplied together. And then 5 to the 4th power means we have 4 5s multiplied together, which is what we have right here. Okay, so now notice we have 6 5s. So we could write this as 5 to the 6th power. That is what exponents mean. We have 6 5s multiplied together, so we can say that would be 5 to the 6th power. So notice a shortcut that we can do. Instead of multiplying out like this and showing the second step right there, instead of doing that, what I can do is I can just look at that first line, 5 squared times 5 to the 4th, and because I'm multiplying, I can then add the exponents. We see a 2 and a 4. If we add the 2 plus 4, we would get 5 to the 6th power. So that is your first law in action, where if you have 2 things being multiplied together with exponents, assuming the base is the same. So here's a 5 as your base, here's a 5 for your base. If the base is the same and you're multiplying, we can add the exponents. And so over here we see law 1, and this is just written in general. So with just the letters, it can be confusing. That's why I showed an example first. But what we have is some number a to some power m times some number a to some power n. And in this case, it was our a would have been 5, and then m would have been 2, and then n would have been 4. And then if you have that where the base is the same, you add the exponents. So whatever it is, you're going to add them together. So here's m plus n added together. And that is your first law. So I'm more concerned that you know how to use the law and not necessarily remembering the letters, a to the m times a to the n, but know how to use the law itself. The second law in action, we see here 3 times 2 squared. So 3 times 2 squared, ignoring the law for a second, we know we should get an answer of 3 times 2 being 6, 6 squared. We know it should be 36, right? Well, the second law is going to show you something else that we can do. So the second law says that if I have a squared here outside of something in parentheses, and there are multiple things here in parentheses, what I can do is I can raise each part. So I can raise the 3 as well as the 2 both to the 2nd power. So what that would be 3 squared times a 2 squared. So it's kind of like distributing almost, where this 2 on the outside you're putting with the 3 and putting with the 2. So it's not distributing, but it's kind of the same type of idea. And 3 squared we know is 9, 2 squared is 4, so we have 9 times 4, which would indeed be 36. So notice we get the same solution. And in this example, it's not really helpful to do it this way, but I want to show you with real numbers so that you can see that this is a true law. And then later in this lesson, we'll show you some examples where it is more practical. Okay, so this second law says that if you have 2 things in parentheses, so a times b, 2 numbers being multiplied together, and it's raised to some power, we'll say power m, then I can take the m and raise both a and b to that power, a to the m power, and then b to the m power. So once again, I'm not concerned with you memorizing all these letters a, b, and m, but know more so how to use the law itself. And then the third law we will look at is when you have something in parentheses raised to a power, and then that whole parentheses raised to a power. So we have a power to a power. We have 2 to the third power, raise that to the second power. So when you see 2 to the third power, we know we have 3 2's multiplied together, right? 2 times 2 times 2. But then the squared means we're going to do that twice. Whatever that is, we're going to square it. We're going to multiply it by itself. So what we have is 2 to the third power would be 2 times 2 times 2. But then when you square it, it means I'm going to multiply that again by itself. 2 times 2 times 2. So to simplify, notice that we have 6 2's multiplied together. So we have 6 2's multiplied together. So we could write that as 2 to the 6th power. And that, it is 64, but we could write it as 2 to the 6th power. So the objective here is to see what's happening with the exponents. So we see we can have a shortcut where instead of writing out this whole second step right here, we know that if we have a power to a power, all we need to do is multiply the exponents. If we multiply 3 times 2, notice we would get the 6 for the exponent. And that is your third law of exponents, where if you have some number raised to some power, to the m power, and that whole expression is raised to the n power, then I can multiply the exponents, where it's going to be m times n. So that would be your third law. And once again, I'm not concerned with you memorizing all the letters, but know the concept and how to use the concept. So to recap, we have 3 laws. When you're multiplying, and we have a same base with some sort of exponent, we can add the exponents. So when you're multiplying, you can add the exponents. When you have multiple things in parentheses raised to a power, you can raise each part of that thing in parentheses to that power. And that's assuming multiplication. So a times b to the m power, you can raise both a and b to that power. And then if you have a power to a power, so m to the n power, you would multiply the exponents. So we have m times n would be the exponent. So now let's look at several examples of how this can be used. Here's the first example, and I'm going to show you the long way to think of it, and then just going right to the shortcut as well after that. So here we have 5 squared times 2 to the third power, and we're going to cube that entire expression. Well, 5 squared would be 5 times 5. 2 cubed would be 2 times 2 times 2. So then if we do that 3 times because of that third power right here, we're going to have our expression. So if I just rearrange the multiplication, so the 5's are together and the 2's are together, notice that we have 1, 2, 3, 4, 5, 6 5's, which would be 5 to the 6th power. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. So that would be 2 to the 9th power. So 5 to the 6th power times 2 to the 9th power would be my solution. Now the shortcut way, instead of going through that entire process, we see that we have this exponent out here, this 3. So I can raise everything to the third power. So what that would be 5 squared to the third power, and then do the 2 to the third power to the third power. So I raise everything in parentheses to that third power. Well, power to a power, you multiply the exponents. 2 times 3 would give you a 6, so 5 to the 6th power. And then a 3 times 3 would give you a 9, so we have 2 to the 9th power. So that is the shortcut. We've combined 2 properties into one, 2 laws into one, where I have to, I guess, distribute, so to speak, that cube out here. And then you're also going to be doing a power to a power, so you have to multiply the exponents. Now the other examples, I'm not going to show you all the long process, but simply get to the shortcuts. So here we have negative 2x squared y to the 4th times 3x y squared. And this is going to be using that first law where I'm multiplying things. And here we see we have a negative 2 times a 3, That would give me a negative 6. And then we have x squared times an x. Those can combine because they have a same base. And when you're multiplying something with the same base, you can add the exponents. So here there's a 2, and then over on the right side there's an assumed 1, x to the first power. So you're multiplying, you can add the 2 and the 1 to get x to the third power. Then over here we have y to the fourth times y squared. So what you can do is you can add the exponents again because you're multiplying. So that would give you y to the sixth power. So my solution would be negative 6x to the third times y to the sixth power. Example 3, we're trying to simplify xy to the third and raising that whole thing to the second power. Remember, when I have an exponent outside of parentheses, I need to raise every part of the parentheses to that second power. So the x, I need to raise the x to the second power, and then I need to raise y to the third to the second power. So x squared stays the same, y to the third squared, you multiply the 3 times 2 to get y to the sixth power. And by the way, you don't need to show all of the steps that I just showed there. I guess only one step here, but you don't need to show the steps necessarily. But I'm showing you the thought process that you should be using at least. Example 4, you have negative x to the fourth squared. And here, remember, raise every part to that second power. Well, this negative is kind of confusing to some people. Think of that as a 1. It's an assumed 1 out here. So what we have is going to be a negative 1, and you can square that. And then x to the fourth, you can square that. So negative 1 squared, you have negative 1 times a negative 1, which becomes a positive 1. And then x to the fourth squared, you have a power to a power, so you multiply the exponents. So that becomes x to the 8th power. So my solution would just be x to the 8th power. And there's 2 parts for this one. I want to show you another example along the same lines. And that is if you raise it to the 3rd power, then what happens? Well, same concept. We have negative 1 to the 3rd power times x to the 4th to the 3rd power. So instead of squared, we have a cube up here. Well, negative 1 to the 3rd power means I'm taking negative 1 times negative 1 times a negative 1. Well, negative 1 times negative 1 times a negative 1 would become a negative 1, because negative times a negative is positive, positive times a negative goes back to a negative. So this becomes a negative 1, and then x to the fourth to the 3rd power, you multiply the 4 times a 3 to get x to the 12th power. So what we have is negative 1x to the 12th power, or simply just negative x to the 12th. And so the concept here is if you have a negative, something negative, and you square it, or any sort of even power, so squared, 4th power, 6th power, 8th power, any even power, it's going to become a positive number. And then if you have it to an odd power, so like to the 3rd power, 5th power, 7th power, it's going to be negative. Okay? And that's a concept that will save you some time in the future. Now example number 5, you have a times a to the 3rd squared times a to the 4th power. Well, first thing you'd like to do is simplify a to the 3rd squared. Here we have a power to a power, so therefore we're going to multiply the exponents. So we have 3 times 2, which becomes a to the 6th power. And then we have everything multiplied together, a, or a to the first, same thing, times a to the 6th times a to the 4th. Because we're multiplying and they have the same base, a base of a, then I can add the exponents. So we have 1 plus 6 plus 4 gives me a to the 11th power. Example 6, we have here 2x squared y z to the 3rd, and then raise that whole thing to the 4th power. Now remember what this means. We're going to raise each part to the 4th power. So 2 to the 4th power, and 2 to the 4th power, and then we have x squared to the 4th power. So we have power to a power, we multiply the exponents. So 2 times 4 gives me an 8. And then y to the 4th power, and then z to the 3rd to the 4th power. So you multiply 3 times 4 to get 12. So my solution would be 2 to the 4th power, x to the 8th, y to the 4th, z to the 12th. But then 2 to the 4th power, you can write that as 16. Because we have 2 times 2 is 4, times 2 is 8, times 1 more 2 would give me 16. Let's look at 3 more examples. Example 7, we see here this expression, and we're trying to simplify. Now this one's a little different looking than the other ones, but we're going to use the principles that we have already learned in this lesson. So to simplify, what I like to do is I would like to distribute 2t squared times t to the 4th, 2t squared times negative 3t squared times the t, and then times the negative 3. Well, here, 2t squared times t to the 4th would give me a 2, and then t squared times t to the 4th, you would add the exponents, and that gives you t to the 6th power. And then multiply by the second term, 2 times a negative 3 would give you a negative 6. T squared times t squared, you add the exponents to get t to the 4th power. 2t squared times a t would give you a 2, and then t squared times t would give you t to the 3rd power. You add the exponents. This is an assumed 1, right? 2 plus 1 gives you 3. And then 2t squared times negative 3 would give you a negative 6, and then the t squared. So my solution would be right there. Example 8, you see this expression, and you're trying to simplify. And this one is a little more confusing because it has 2 sets of variables, where the variable is the base for x, and the variable y is also the exponent. But still the same principles, where if you look at this first expression right here, we have a power to a power. We have x squared raised to the y power. Well, when you have a power to a power, what you do is you multiply the exponents. So we take 2 times y, or you just write that as 2y. Same thing over here. You have power to a power. Y times 4 would give you 4y, 4 times y. So all I do is write it like that. X to the 2y power times x to the 4y power. But then you're multiplying and the base is the same. They both have a base of x. So therefore I can add the exponents, 2y plus 4y, which would give me a 6y. And that would be my solution. Example 9, this one is the most complicated only because there are no numbers anymore. But the principles are all the same, and you know how to do all of this up to this point. So what we do is we want to distribute, right? We want to take this times that, and then this times that. Well, when you multiply, you want to add the exponents. The bases are the same. They both have a base of a, so I'm going to add the exponents, which would be x minus y, and then plus x plus y. We're adding the exponents there and there. Well, we know how to add like terms. Negative y plus y would cancel. And then we just have x plus x, which gives me a 2x. So that first part would be a to the 2x power. And then same thing when I distribute to the second term. We have a, and then add the exponents, x minus y plus y. Negative y plus y would cancel. So I'm left with just a to the x power. And that would be my solution, a to the 2x plus a to the x power. And that concludes our lesson for today. We've learned the 3 laws of exponents, or 3 of the laws. There are some other ones we'll discuss later. And we've learned how to use them with these different examples. So that concludes our lesson for today, and we will see you next time.